is a vertical circular motion, and this is a bob. And here, so you are going to talk after B position crossing. So here we are discussing, we are saying that once it crosses, it crosses the B position, this position, it crossing, what will happen? What will happen? The scenario is, here we are saying once it crosses the B position, what is going to happen? So the tensions once here what happens? Tension becomes tension is going to decrease. Tension is going to decrease. Is going to decrease. Going to decrease. Velocity velocity is not going to be zero. Velocity is not going to be zero. Because why it is not becoming zero? Because you have imparted the velocity more. That is why it is not going to be zero. Because as tension is going to decrease, means tension is going to be becoming zero because the angle is increasing. As the angle is going to be increased, the tension value will be increased. As you have seen the equation, T theta is equal to mv square, mv theta whole square by L plus mg cos theta. We know that when the cos function is angle is increasing, you will see the value of the tension is going to will be decreased, right? Now let us see about the tension once it crosses the B. Next, what happens? It's making a velocity. Now you are going to see the situation that once it is decreasing, the tension here once it becomes zero, tension is becoming zero, means the string will have slack. It will lose, string will have slack. Slack means it loses, it means it loses its pull force. Its pull force. Its pull force. Pull force. So what will happen if it slacks? So it will lose its direction. It will lose its direction. It won't make circular path. Then the path followed by the motion of the path followed the path followed by the motion of the object by the motion of the object by the motion of the object is parabola. Parabolic path. Parabolic path means it comes like this. It comes like this. Parabolic path. Are we clear? Are we clear? So what is going to happen once it decreases? It has decreases. If the situation it has reaches to zero, then the string will have slack. What do you mean by slack? Means it loses its pull force. No, there won't be any force to hold it to make it a perfect circle. So it will take a diversion and it will make a parabolic path. That is the motion of the object is parabolic path. Are we clear? Right? So this we can make that it follows circular plus projectile motion. Circle, making a circle plus projectile motion also we can say sometimes. 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 Right. For a critical velocity. For a critical velocity. For a critical velocity. So the body, this is a body, this is a bob, and to reach to the this is B point and this is a C point to C point. Then it must here we are saying the specific condition means compulsory condition. It reaches to the C point. It reaches the point C. Then the minimum velocity, then the minimum velocity to be given is root 5gl. How much? Root 5gl. Root 5gl. Root 5gl. Here we can also say the tension is greater than or equal to 0. You can say the tension should be equal to 0 or greater than or equal to 0. Then at this stage, what is the velocity you must impart to the body is that is root 5gl. What is the velocity? Root 5gl. We'll derive this one. Don't worry. Okay. We'll derive this. How this came, the equation also will derive. But to make a note that you will have a basic idea that what is the velocity to give the to reach the C position, that is root 5gl. At least to reach, what I'm saying here is at least to reach the C position, it should be around root 5gl. That is what I'm saying. Right? We'll discuss this. Okay. To make a circle, to make a circle, to make a circle, the critical velocity should be minimum. The critical velocity, the critical velocity is minimum. Critical velocity minimum to make a circle. Critical conditions TC, that is TC. We already find the tension value. What is the value? That is mv1 square by me1 square by L minus 5 mg. So we have given some v1 velocity and it has reached over here. So TC at this point, tension at this maximum point, tension is maximum at this point, tension is minimum. Tension is minimum, not maximum. Tension is minimum at this point. Tension is maximum at this point. Remember, as we go, it decreases. Tension is maximum here. Now I said TC is equal to 0. TC, because TC is equal to 0. This is the condition we are finding for a body to be making in a circular motion. We are making that tension is equal to 0. And what you get here, mv1 square by L is equal to 5 mg. And 5 mg to transport this side, 5 mg is equal to mv1 square by L. mm cancel. You are getting v1 square is equal to 5g, and v1 square is equal to v1 is equal to, that you are getting here is root 5gl. This is the equation, right? We derived it. So what should be the velocity at this point? What should be the velocity to, you have to give root 5gl. Are we clear? Are we clear? Okay now, right? We have this already, we derived in the previous classes. Tension at C, what is the standard equation we got? mv1 square by L minus 5 mg. From that equation only, what I have derived, that at this point, the critical velocity, at this tension, we said it is 0. And substituting this equation mv1 square by L minus 5 mg, you transport to this side. 5 mg is equal to mv1 square by L. M cancel. You are getting v1 square is equal to 5gl. The square goes to that side. You are getting v1 is equal to root 5gl. Are we clear? Right? So next case, we are discussing minimum velocity to reach B position. That is this is a circle we are making, and this is the A point, and to reach B position, this is the B position. So what should be the minimum velocity to at least reach B position? We know that already when it comes to B position, the velocity, the final velocity will be equal to V equal to 0. Already we discussed. Now, following the law of conservation of energy theorem, law of conservation of energy, So what is that? U initial plus k initial is equal to u final plus k final. This is the equation we made it. Now we know that u initial. What will be the u initial? U initial at this reference u initial will be mgh, but h here is here mgh will be equal to 0 because h is equal to 0. And we have the u initial potential energy 0, and you are given some velocity that is k initial, that is half mv1 square. So this is the initial velocity, that is k half mv1 square, and at reaching to the b position, it will have some final velocity, some height, that is uf, that is the mgl, and final kinetic energy you will have 0, because since velocity is equal to 0. Why you have final velocity is 0? Because velocity is equal to 0 at the final stage. Now there it goes. So if you use this all these terms in this equation, what you'll get here is mgh is 0. So 0 plus k initial is half mv1 square. U final is what? mgl, and kf is 0. So if you cancel cancel, you are getting v1 square is equal to 2gl. So v1 is equal to root 2gl. So what should be the velocity to be given, minimum velocity to reach at least b position is, that is v1 is equal to root 2gl. Are we clear? Are we clear? Now in the previous class, we discussed what is the minimum velocity to make a complete circle is v1 is equal to root 5gl, and to reach, and here in this case we are discussing that velocity should what should be the minimum velocity to reach b position, that is v1. Are we clear? Okay now, right? Okay, you can write it. We are going to what will happen, what will happen, what will happen if the velocity, if the velocity is given greater than 0 and less than root 2gl. What will happen? What will happen? It makes, what will happen? What will you see here? It makes oscillations. It makes oscillations. What type of oscillations? Damped oscillations. Means damped oscillation means decreasing of the oscillations. As the diagrammatic representations, as it goes up, down, and then next you see like this, next like this, next you get like this, next simple like this, it stops like this. This is the scenario you are going to see, the type of the motion you are going to see, right? It's the case we are discussing if the velocity root 2gl and the velocity is v1 and it is greater than 5gl. So these are the conditions we are going. If it is given greater than 2gl, and if the velocity is given less than 5 root 5gl, what are you going to see? Then the you will the case is the what will happen, then the tension, then tension becomes zero, tension becomes zero between between B and C position, between B and C position, between B and C position, then the body, then the body of the motion, then the body of the motion has have parabolic path, a parabolic path, a parabolic path. So let us see what we have the parabolic path, that is we have the velocity of b at the b position, the standard formula, that is under root of v1 square minus v1 square v1 square minus 2gl. 2gl. So what v1 square minus 2gl. Already we derived this expression. You can see in the previous class, velocity at the B position is under root of v1 square minus 2gl. Right? We discussed already this one. Next, so what is the velocity you are giving here? What is the impartation? What is the minimum velocity you are giving here? That is 5gl. 5gl. Already we discussed now, we have given the velocity. See, this is the scenario. You are giving the minimum velocity, that is 5gl, and you are giving, so at the B positions, you are having what? B position, B position, that is under root of V1 square minus 2gl. So this is the velocity. Again, this is the V1 velocity you're giving, and it's going there at the B position. You are giving the standard equation for at this position is BB is equal to under root of V1 square minus 2gl. So what is the V1 value here? 5gl minus 2gl. You are getting VB is equal to root 3gl. Right? Are we clear? Are we clear? Now this is B position finished. Now it is reaching to C position. At this position, we had the formula, that is the velocity is under velocity at C position, that is under root of V1 square minus 4gl. This is the equation we had already derived. So here at this position, velocity V1 is equal to V1 square VC is equal to under root of V1 square minus 4gl. This is only we had this. Now VC, you are giving the minimum velocity, that is V1 is equal to root 5gl. Now, if you substitute this expression in the V1, you get VC is equal to under root of 5gl minus 4gl. That is VC is equal to root gl. VC is equal to root gl. So at the top, the critical velocity to reach the C position VC is root gl. Root gl. At this position, what is the velocity you are having? VC is equal to root VB position. VB position you are having how much? Root 3gl. Right? We found out here V1 position is root 5gl, here root 3gl, here at this point we are having VC equal to root gl. Are we clear? Right? Circular motion ఇచ్చాను. Circular motion ఇచ్చేసి ఇక్కడ నేను ఎంత ఇచ్చాను? V1 is equal to root 10gl ఇచ్చాను. root 10gl ఇచ్చాను. అరే నేను ఇందాక మాట్లాడుకునేది V1 velocity is should be given to minimum velocity root 5gl. ఇది అంతకంటే ఎక్కువ వస్తుంది కదా? రూట్ ఎన్జిఎల్ ఉన్నదానికంటే ఎక్కువ అంటే కంప్లీట్ కంపల్సరీ ఆ బాడీ అనేది సర్క్యులర్ మోషన్లోకి వెళ్తుంది. అంతే కదా ఇక్కడ మీనింగ్. ఇది V1 velocity ఈజ్ గ్రేటర్ దెన్ రూట్ 5gl. ఇది రూట్ 10gl కంటే రూట్ 5gl కంటే ఎక్కువ ఉంది అంటే దీని మీనింగ్ ఏంటి? కంపల్సరీ సర్క్యులర్ మోషన్ వెళ్తుంది, ఉన్నదానికంటే ఎక్కువ ఇస్తున్నాం. అప్పుడు ఏం జరుగుతుంది? వాట్ ఈస్ ద velocity at an angle theta అని అప్పుడు ఈక్వేషన్ ఏం రాస్తామంటే we write that is v1 square minus standard equation 2gl of 1 minus cos theta. ఇదే కదా మన ఎక్స్ప్రెషన్ v theta is equal to under root of v1 square minus 2gl of 1 minus cos theta. సో ఈ పొజిషన్ రావాలనుకుంటే ఏమని చేస్తావు? ఈ పొజిషన్ దగ్గర నీకు తెలుసు ఎంత వస్తుంది ఇక్కడ వెలాసిటీ. వి థీటా ఈజ్ ఈక్వల్ టు అండర్ రూట్ ఆఫ్ థీటా వాల్యూ ఎంత? ఇక్కడ థీటా వాల్యూ 180 degrees. 180 degrees ఇస్తే నీకు V1 స్క్వేర్ మైనస్ 4gl వస్తుంది. అంటే వి థీటా నువ్వు ఇచ్చిన వెలాసిటీ ఎంత? ఇక్కడ రూట్ 10gl ఇచ్చావు. అంటే 10gl అంటే రూట్ 10gl అంటే V1 స్క్వేర్ ఎంత? 10gl. 10gl మైనస్ 4gl. సో వి థీటా ఎట్ సి పొజిషన్ అంటే ఇక్కడ వి థీటా అంటే దీని డైరెక్ట్గా విసి పొజిషన్ ఫైండ్ అవుట్ చేస్తున్నాం. అప్పుడు ఎంత వస్తుంది? 6gl, రూట్ 6gl. సో వాట్ ఈస్ ద వెలాసిటీ ఎట్ సి పొజిషన్ అడుగుతున్నాడు. అప్పుడు ఏం ఫార్ములా? విసి ఈజ్ ఈక్వల్ టు రూట్ 6gl. సపోజ్ నీకు బి పొజిషన్ అడిగిన అనుకో, సపోజ్ ఇక్కడ బి పొజిషన్ దగ్గర ఎంత అని అడిగిన అనుకో, అప్పుడు ఏం చేస్తావు? విబి ఈజ్ ఈక్వల్ టు అండర్ రూట్ ఆఫ్ V1 స్క్వేర్ మైనస్ ఎంత? 2gl 2gl cos ఎంత ఉందమ్మా b స్క్వేర్ v1 స్క్వేర్ మైనస్ 2gl కదా 2gl అంటే cos 90 is 0 2gl అప్పుడు ఎంత వస్తుంది vb at this position what will be here 10gl minus 2gl that is vb is equal to ఎంత ఉంటుంది root 8gl రైట్ b పొజిషన్ అయితే root 8gl అప్పుడు ఇక్కడ ఎంత ఉంటుంది 6gl క్లియర్ అర్థమైందా బి పొజిషన్ సి పొజిషన్ బి పొజిషన్ దగ్గర రూట్ 8gl ఇక్కడికి వచ్చేసరికి 6gl వెలాసిటీ తగ్గిపోతుంది సర్క్యులర్ మోషన్ చేస్తుంది వర్టికల్ సర్క్యులర్ మోషన్ ఇదే కేసులో నేను ఏం తీసుకుంటున్నా జిగ్నేష్ టర్న్ ఆన్ యువర్ వీడియో ఐఎమ్ టేకింగ్ రాడ్ అంటే ఇంతకుముందు ఏమో దారం తీసుకున్నాను స్ట్రింగ్ తీసుకున్నాను వాట్ ఐఎమ్ టేకింగ్ నౌ రాడ్ అంటే వాట్ ఈస్ ద హోల్డింగ్ ఆఫ్ ది ఆబ్జెక్ట్ ఇట్ ఈస్ రాడ్ నాట్ స్ట్రింగ్ ఓకే if you are taking the if we are taking rod in place of string tension does not become zero అయ్యే ప్రసక్తే లేదు టెన్షన్ జీరో కాదు ఎందుకంటే అది రాడ్ కదా దారం అయితే ఏదైనా కొంచెం లైట్ వెయిట్ ఉంటుంది కాబట్టి అది టెన్షన్ అనేది కొంచెం కోల్పోతుంది కానీ ఇందులో ఖచ్చితంగా పట్టు ఉంటుంది విల్ హ్యావ్ సమ్ పుల్లింగ్ ఫోర్స్ కంపల్సరీ దట్ ఈస్ వై వీ కెనాట్ సే ద టెన్షన్ డస్ నాట్ బికమ్ జీరో ఆర్ ఎల్స్ యూ సీ ఇన్ యర్ డైలీ లైఫ్ tubeless tires also like this and if you throw an object like this is also here we are taking a tires or grooves in this situation tension does not if you throw a ball also tension does not become so these are the two cases tension is not zero taking a tire in that if you throw a ball this also will not become zero if you are taking a rod in place of string tension does not become zero this is also pick up please make a note this is a note if you have string it will try to become zero but if you are taking a rod this does not become a zero want to be noted this you are going to calculate the same thing but when you're taking these conditions we have seen that in while taking a string and we observe that the motions at different positions and there what you are seeing here there is the tension is becoming zero per string but for the rod it is not because it has some pulling force the tension has some pulling force that's why it does not become at c position vc is equal to under root of v1 square minus 4gl so you see as you go to the maximum position the c position the velocity will become zero so v1 square minus 4gl under root the square goes to this side you will have that v1 square minus 4gl equal to 0 v1 square is equal to 4gl then v1 is equal to root 4gl so what will be the minimum velocity to be given to reach the C position for this kind of bodies when you are having a uniform rod or when you take a tire and you throw a ball to make so you are taking a tire and throw a ball to make a circle you must give the minimum velocity v1 is equal to 4gl for rod and tires throwing a ball for rod and tires the minimum velocity should be v1 is equal to root 4gl are we clear v1 is equal to root 4gl but string what you got the velocity what is the velocity you got that is root 5gl are we clear ఓకేనా ఇక్కడ అర్థమైందా ఇది కండిషన్ ఖచ్చితంగా దానికి దీనికి డిఫరెన్స్ అంటే స్ట్రింగ్ కి రాడ్కి ఏమైనా తేడా ఉందంటే అరే నువ్వు స్ట్రింగ్ కి ఖచ్చితంగా నువ్వు 5gl ఇవ్వాలరా బాబు అని చెప్తాం ఇంకోటి నువ్వు రాడ్ తీసుకున్నావు అనుకో లేదా టైర్లో తీసుకున్నావు నువ్వు మినిమం వెలాసిటీ ఎంత ఇవ్వాలి 4 root 4gl ఇవ్వాలి అంతే. అంటే ఆబ్జెక్ట్స్ బట్టి మారుతుంటాయి వెలాసిటీస్. అర్థమైందా? నువ్వు అన్నిటికి ఇప్పుడు దారంకి కట్టి నువ్వు వేస్తే ఆహ్, కొంచెం ఎక్కువ ఇవ్వాల్సొస్తది వెలాసిటీ. అదే ఎందుకంటే అది సపోర్ట్ లేదు దానికి. పుల్లింగ్ ఫోర్స్ లేదు. అదే రాడ్‌కి ఇచ్చినావనుకో కొద్దిగా ఇట్లా కొట్టినావనుకో, రాడ్ సపోర్ట్ ఉండి బాబుకి అటాచ్ ఉందనుకో, అది ఖచ్చితంగా దానికి టెన్షన్ ఎంతో 0 కాదు. ఖచ్చితంగా అది సర్క్యులర్ మోషన్‌లో చేయగలుగుతది. అప్పుడు నీకు తగ్గుతది. ఉన్నదానికంటే కొంచెం తగ్గుతది. స్ట్రింగ్‌కి ఉన్నంత వెలాసిటీకి రాడ్‌కి ఇయ్యాల్సినంత అవసరం లేదు. అది చెప్తుంది ఇక్కడ మీనింగ్. ఇక్కడ ఒక స్లోప్ ఉంది. వెడ్జ్ లాంటిది. ఇక్కడ బాడీ మాస్ ఎం పెట్టాను. అయితే ఇది కొంచెం దిక్కు ట్రావెల్ అయింది. ఇలా ఒక సర్కిల్ మోషన్స్ చేసింది. ఒక నిమిషం. ఓకే. ఇలా ఆబ్జెక్ట్ వచ్చింది. ఇట్ ఈస్ మేకింగ్ ఎ సర్క్యులర్ మోషన్. అంటే ఖచ్చితంగా నువ్వు ఏం చెప్తావు? బాడీ స్లోప్ అవుతుంది. అంటే కిందకొచ్చేసింది. దెన్ ఇట్ హాస్ ఫైనల్లీ మేడ్ ఎ సర్క్యులర్ మోషన్. సో, ఎంత వెలాసిటీ ఉండాలి ఇక్కడికి సర్క్యులర్ మోషన్ చేయాలంటే? ఇట్ షుడ్ బి ద మినిమమ్ వెలాసిటీ వి ఈజ్ ఈక్వల్ టు ఖచ్చితంగా నువ్వు చెప్తావు √πgl అని. అంతే కదా! ఇక్కడైతే నీకు తెలిసిపోతుంది. √πgl. బాడీ ఇక్కడ నుంచి స్లోప్ అవుతూ జారుకుంటూ వచ్చి ఇక్కడి వరకొచ్చి సర్క్యులర్ మోషన్ చేసిందంటే మీనింగ్ ఏంటంటే కంపల్సరీ ఆ సర్క్యులర్ మోషన్ చేస్తుందంటే దాని మినిమం వెలాసిటీ ఎంత ఉండాలి? √5gl ఉండాలని తెలుసు. ఆర్ వి క్లియర్? You made to fall, it is sliding and it has gained some energy and till here it reached and it has a velocity √5gl so that it is making a circular motion. Now, what is the height? It should be. The question is, what should be the height? It should be kept. That is my question. Now, we know that according to law of conservation of energy, energy, we can say loss of potential energy loss of potential energy is equal to gain in kinetic energy. This principle, this is also law of conservation energy. We are using the principle law of conservation, loss of potential energy equal to gain in kinetic energy. ఎక్కడైతే లాస్ అవుతుందో ఒక సైడ్ గెయిన్ అవుతుంది అనేది తగ్గిపోతుంది, ఇంకో సైడ్ గెయిన్ ఇన్ కైనెటిక్ అంటే సో ఇట్ ఈస్ ఫాలింగ్ ఫ్రమ్ సర్టన్ హైట్ మీన్స్ దెర్ ఇస్ ద లాస్ ఇన్ పొటెన్షియల్ ఎనర్జీ, దెన్ వి రైట్ ఇట్ హియర్ mgh because it's coming from a height, and there is a gain in kinetic. At last you see here the object has come and it is moving means there is a kinetic energy that we write it as half mv square, half mv square. So cancel, you are getting here v square is equal to 2gh. If you simplify, you get v square is equal to 2gh. Therefore, v is equal to √2gh. Right? Already we said that v is equal to √2gh. We got the equation that is v is equal to √2gh. To make a circular motion, so it is making a circular motion with radius r. So compulsory, in place of L, I'm going to replace with L as R, that is √5gr. Now v is equal to √2gh. Just use the equation of the velocity, which is √5gr. Just √5gr is equal to √2gh. If you remove both sides square root, you get 5gr is equal to 2gh. Gg get cancelled. Therefore, h is equal to, you are getting 5r by 2. So h is equal to 2.5 into r. 2. What should be the height? Should be kept in order to have a circular motion. The height should be 2.5 r. Right? What is the height? h is equal to 2.5 r. అంటే ఇక్కడ మీకు ఏం చెప్తున్నాను, నాకు ఒక రేడియస్ 1 సెంటీమీటర్ కావాలి. అప్పుడు ఈ హైట్ ఆఫ్ దిస్ వెజ్ ఎంత ఉండాలి అని అన్నాడు. అంటే జస్ట్ సప్లీ చేసుకో, 2.5 ఇంటూ 1 మీటర్, 1 మీటర్ రేడియస్ ఆఫ్ సర్కిల్ కొట్టాలి. 1 ఇజ్ ఈక్వల్ టు హైట్, హెచ్ ఇజ్ ఈక్వల్ టు 2.5. అంటే ఎంత హైట్ ఉండాలి అప్పుడు? హెచ్ ఇజ్ ఈక్వల్ టు 2.5 మీటర్స్ ఉండాలి అంతే. And we'll discuss those. So I'll take some of the examples and solve it, and you take the examples as a concepts and apply for your worksheets.